Hi everyone, welcome to this video which is on section 4.6 in our textbook. We're going to talk about congruence in right triangles. So far we've done all different ways that we could show triangles are congruent. Side, 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 angle, that type of stuff. But they were all just triangles. What about if they're right triangles? So let's look at that in this section. I have on the board behind me three different ways to show that right triangles are congruent, but I also compared them to regular triangles. So if you look at this first triangle right here, first of all, it has to be a right triangle. If I have a right triangle, then all I need are the two legs. If two legs of one right triangle are congruent to two legs of another right triangle, then the whole triangle is congruent. That's the leg-leg congruence theorem. And I want to show you why it works. That's why I have this diagram on the board. Because here's the leg and here's the leg, but notice what's right in the middle is that right angle. So this is the same as side angle side in any other triangle. But we don't have to state that angle. All we need to state is that it's a right triangle. If we know it's a right triangle, we've stated that, and both legs, then we can just say leg-leg congruence. All right, here is an angle, a triangle, a right triangle. The hypotenuse is congruent to one of the acute angles. That is also enough to show that two right triangles are congruent. It's the hypotenuse angle. You just have to make sure that the angle is the corresponding angle in order to use it. So if the hypotenuse and a corresponding acute angle are congruent in a right triangle, then the triangles are congruent by HA congruence theorem, hypotenuse angle. I drew so you could see why this looks the same as angle, angle, side. It's just we don't have to state this angle, and that side. All we have to state is it's a right triangle, the hypotenuse, and a corresponding acute angle, and we can say HA. Down here, I have another right triangle. This time, I don't have the hypotenuse and an angle. I have a leg and an angle, corresponding angle, corresponding leg. That's important. Notice this is also a corresponding angle, corresponding leg. Different, but as long as it corresponds to the other one, it works. This would be called the leg angle congruence theorem. In this case, it would work because it would be the same as angle side angle, just to show you the two different ways why it works. In this one, it would work because it would be the same as angle, angle, side. So these are all congruence theorems that you already know, or postulates that you already know. It's just when applied in a right triangle, we can say it with less detail because we're stating that we are dealing with a right triangle. Now there's one right triangle congruence theorem that is completely different, and that is HL. H for hypotenuse, L for leg. If I have a right triangle, the hypotenuse of one right triangle is congruent to another, and the one corresponding leg is congruent to another triangle, right triangle, then that's enough. So we have to state it's a right triangle, the hypotenuse, and the corresponding leg. Why does this work? Because this doesn't have a corresponding. In fact, it would be side-side angle, and in another triangle, side-side angle does not work. In a right triangle, though, it does. Don't write side-side angle. You have to write HL. But it does work, and here's why. If I have side-side and an angle, there are too many options for the other angle to be in any other triangle. This angle right here, there's just too many options for that other angle to be. But if it's a right triangle, there aren't. The right triangle solidifies it, and therefore there's only one possible triangle that we can make, as long as it's a hypotenuse and one leg. So that's why we have this unique theorem for dealing with right triangles. Here's an example of applying this. We have a proof. This proof involves right triangles, and all that we are given is the figure. That's it. And we are told to prove that AD is congruent to BC. Segment AD is congruent to segment BC. How would we go about doing that? So we know these are right triangles because they're designated that way, and these two lines are parallel because that's given in the diagram. So where do we start? Remember I told you, always start with the givens. So I listed what I just said we knew from the diagram was that these two angles are right angles and that these two segments are parallel. So I listed that as the given. What does it mean that those two angles are right angles? If those are right angles, what do I know about those triangles? Those must be right triangles. I need to establish that they're right triangles in order to use my right triangle congruence theorem. So I need to write that down. Okay, I've listed that those two triangles are right triangles. This triangle and that triangle are right. I still need some more information than just that right angle. If you see this side, AC, is shared, it's a leg on both of those triangles, so we can list that. AC is congruent to itself because it is a leg. And then, because those lines are parallel, do you see that we would have alternate interior angles? This same AC would be a transversal that goes through those two parallel lines. So we'll have these alternate interior angles as well. So let's list those. Okay, I listed my leg, which is AC and CA, or AC and AC, doesn't matter. That's the reflexive property. It's congruent to itself. So there is my leg. And angle DCA is congruent to angle BAC. Why? Because alternate interior angles, those parallel lines, imply alternate interior angles. Well, now I have a leg and I have an angle, so now I can say my triangles are congruent. So because they're right triangles, all I had to state was a leg and an angle. That's enough. Triangle DCA is congruent to triangle BCA. The thing is that's not what they asked for. They asked us to prove those two segments are congruent. Can I state that now? If both triangles are congruent to each other, then aren't all their corresponding parts also congruent? So I will list that last and write CPCTC, and I'm done. All right, let's look at some figures and see, just by looking, would we be able to prove that these two triangles are congruent? So if I look at this figure, the way it's labeled, I see these two angles, angle B and angle D, are right angles. And I see these two angles here, both of them at A, are congruent to each other. So are these two triangles, can I show that they're congruent? If I can, I need to make a congruent statement, and I need to state which theorem I would use. So I have two angles. All I need is a side. Do I have a side? Don't they share AC? And in both triangles, isn't AC, it's the hypotenuse, isn't it? So I can say triangle ABC is congruent to triangle, and now I have to be careful, corresponding order. If I go ABC, then I need to go ADC. ADC. And I have the hypotenuse and I have an angle. So how do I know that? By hypotenuse angle congruence theorem. There we go. This looks like the exact same diagram, just labeled differently. And now I do not have any other angles besides the right angles, but I do have these two legs. Would that be enough? Just the leg. Again, I have this shared side. it's EG, and it happens to be the hypotenuse of both of those triangles. So I have leg, and I have the hypotenuse. Is that enough? Oh, that's the HL. That's the special case for right triangles. So I can make my congruent statement. Make sure you do that. So I could say in corresponding order, however I want to do it. How about EFG? Triangle EFG is congruent to triangle, and corresponding would be EHG by HL. So if I wanted to prove this, I would list what's given. I would add EG is congruent to itself by the reflexive property, and it's the hypotenuse, which that's enough, and then I'd use HL. Okay, what about this diagram? Can I show these two triangles are congruent? And if so, what would be my congruent statement? And what theorem would I use? They are both right triangles. I'm given this leg here. They share this leg in common. So I could list XY as congruent to itself. And so I have a leg and another leg. Is that enough? Yes, that's enough. In a right triangle, the two legs is enough. Remember, because it's the same as side angle side. So yes, I can do it using leg, leg. Okay, make sure your notebook has these theorems in it so that you can use them in proving triangles, and we're done with that aspect for now. So this is all I'm going to show you for this section. Hopefully it's enough to get you started working on these different proofs. So I'll see you guys next time.